Hello, Math 9. Today we are going to go through circle properties, which is more like a real life scenario, and context having questions. A lot of questions that I am going to go through will be from textbook, either from Math Makes Sense 9 or Math Link 9. So, material that we need for today is some kind of loose leaves because we are going to copy question. And during that copying questions time, I will give you some idea that you can press pause for the video so it gives enough of time for you to write down the context or draw the diagram even. You don't need a geometry tool even though precision may help you. We also may need calculator, especially a situation where we are using Pythagorean theorem. Let's go with classroom example number 1. Two poles with radii, which is plural form of radius, of 18 centimeter and 7 centimeter are connected by a single metal band joining their centers and points of their outer edges. This is shown below as a diagram. The question is asking us to determine the length of the metal band that is needed if AB is tangent to both poles. So I want you to pause this video for about a minute. Copy the diagram. You don't need to copy the whole context. Then I'm going to go through step by step how to solve this question. Let's see. First of all, one of the most important clue that is given is our 90-degree angle. Because the line AB is basically tangent to circle O and circle C. So tangent is a fancy way of saying that we are having 90 degree. Whenever you have a 90 degree, just for the heads up, it is important to connect the idea of C, A, B, C's hypotenuse, A and B, other sides of right angle triangle for the Pythagorean theorem. Let's see what clue that we have. First of all, we have AO side is given, AB side is given, and another radius BC is given. In the end, we are trying to find our length O and C. The thing about this situation is we do not have any specific triangle. However, if you look through, we can actually make two triangles using this one trapezoid looking structure. What I'm going to do is I'm going to connect point O and B. And I'm going to call this triangle number 1, call this triangle number 2. Because if I redraw, and it's not drawn on scale by the way, triangle number 1, A, O, B, we can use 7 centimeter, 60 centimeter to figure out our hypotenuse B and O. Why am I finding this B and O? Is because, well, that B and O become our second triangles, one of the side. It's not hypotenuse, but we can still use it. The reason that we can use it is because even though I didn't draw in scale, but this line is also tangential to the point B, which is a fancy way of saying only one point is touching. So we can practically use it for another Pythagorean theorem. Long story short, let's do this. Imagine BO is my x. Then x squared is equal to 60 squared plus 7 squared. And I can put square root on it. If you want to do it as a one step, don't forget the unit. The unit is centimeter. So right now, I am using just practical and non-modified format of a squared plus b squared is equal to c squared, which is simple calculation, and we don't need to do any other type of complex modification. All we gotta do is putting a square root on. I am going to take my calculator. Sadly, I don't have a calculator at the moment, so I have to rely on my cell phone, which in your case, you guys know, that's no bueno. We shouldn't use that. All right, 60 times 60 plus, bracket open, 7 times 7, that's 49. Then I have square root 3,649 centimeter. Know the fact that this is hypotenuse of one of the triangle, but on the other hand, if I look at triangle number 2, again, it's not drawn as a scale. It is one of the height or length, if you will. And the other part, radius, is given, so that we can find our length CO, which in this case I put it as y. Also, know the fact that I didn't actually solve square root 3,649 because I have the feeling it's a nasty number, or I don't know, it can be a good number it turned out, but highly possible there's some kind of non-natural number, which is irrational number, may not repeat forever going on. So just for the heads up, it's probably a good idea to use a specific square root form. Having that in your mind, I'm going to do the same thing. Square, a square, b square is equal to c square. 18 times 18, 324. 3,649. That provides you square root 3,973 square root centimeter is my metal connector between O and C. And because of the area, I don't have a lack of space, so I'm just gonna erase some of them. If I, round it up, 3,973, let's put square root first. Square root 3,973, bracket close, is equal to 63.03 centimeter. That is how you solve the first problem. Let's go with our next example. A radar station R tracks all ships in a circle with radius of 50 kilometers. A ship enters this radar zone and the station tracks it for 62.5 kilometers until the ship passes out of range. What is the closest distance the ship comes to the radar station? Justify your answer. So this question is asking us to find the closest distance the ship comes with the radar station, which technically you can have a connection here and here, but this is probably the closest distance that we can find and measure. Now, having that in your mind, let's pause this video for about a minute. I want you to copy the diagram, and I'm going to proceed our question number 2, solving step. All right, then let's solve this problem. Like I mentioned in previous one, let's say ship goes from one area to another. Technically, as soon as the ship go inside of this circle, you're under the radar. So technically from here all the way to there, we can have a contact with the radio wave of the radar. The only thing is we are trying to find the shortest distance. Thus, the shortest distance that you can find is when the part of the radius is bisecting the chord. Talking about that, I like to say this is a perpendicular bisector question. Fortunately, we know one thing. Imagine this is point A, that's point B. We know that the halfway until here, the length of A to middle, B to middle, aka in this case radius, is exact half. And that is important because I can create our right angle triangle relationship to find out this short distance x, if you will. I have a hard time seeing it, but in any case, we know that this is point R, that's point A, then let's say that's point C. Because what I'm going to do is, I'm going to draw, again, not in the scale, just generic enough, right angle triangle. But point is important. I'm going to have A over on the left side, R above, and C below, and that's 90 degrees. One thing that we know is the line AR is basically my radius, and radius is given as 50 kilo. Technically it says 50.0, but who cares? 50.0 is just a fancy way of saying 50. Now we need to have A and C. A and C is actually midway of the ship's path. So that's basically 62.5. I got to divide it by 2. So 62.5 divided by 2, according to my calculator, it gives you 31.25 kilometer. Once we figure that out, then I can actually find the RC distance. The only thing is, this is a part where instead of using our good old Pythagorean theorem the way it is, I actually need to rearrange so the hypotenuse is basically subtracting one of them. So I can just say b squared is equal to c squared minus a squared. And b is like my x. Let's put it that way. Now let's punch some number in. 50 square, which is c squared, minus 31.25 square. If I put square root on it, that's, well, typically all we got to do. You can use multiple step, or you can just use one step and then do. I'm going to do one step. Square root button open. 50 times 50, bracket close, minus, bracket open, 31.25 times 31.25, bracket close twice. Then I have 39.03123 ... kilometer. Then I can round it up to nearest 100. I rounded up to nearest 100 because I forgot what the question asked you to round up to. If it's whole number, 39 kilo. Nearest 10, 39.0. Nearest 100, 39.03 kilometer. That is the shortest distance between the ship and the radar station. That's another example. All right, this is more angle question now. So as soon as you see an angle, probably it is highly possible that it asks about central angle and inscribed angle. But in any case, let's go through. Triangle A, B, and C is a site investigated by a group of archaeologists. Triangle A, B, and C is inscribed in a circle, center O. The angle AOB is given as 100. COB is given at 140 degrees. Our job is determining degree X, Y, and Z. And when I look at it, it seems like Y is ABC. So whole angle over here. Z look like one part of an angle. Based on that, let's give it a shot. Oh, of course, I am going to ask you to pause the video for about a minute again so that you can draw the whole thing. All right, without further ado, let's write some clue that we know. Even though it is an angle question, you need to know about, do I know that several sides are equal to, aka, is there any isosceles triangle or equilateral triangle? In fact, we know that the length BO, length CO, and length AO are all equivalent distance from the center. Because all the line that I put over here with the tick system, those are radius. That means they have to share the same length. If it's 5 centimeter, that's 5 centimeter to the other side too. Having that in your mind, that provides you some of the clue already, especially when we talk about this angle Z, because this Z must be identical to the other side too over here. Let's find out each of the clue now. Let's talk about angle X first. X, fortunately, is an easiest one because I have an angle over here given by the question. I also know the angle down there. All I gotta do is finding this unknown X over here. How can I find the angle X that case? We already know that it's 360 is a maximum angle that you can have as a complete round. So 360 degrees where I can start, minus what I know, 100 degree minus 140 degree, which is fancy way of saying 360 degree minus 240 degree, which give me, what is that, 120 degree. This is just simple subtraction. Thus, we now know that I gotta be precise, sorry. Instead of X, now I know that this is 120 degree. Yay. Now let's think about the angle Z. Now, if I draw the triangle that has Z in it, we just found one of the angle. We know that the line AO and CO are radius. So that's a fancy way of saying these two are identical. So technically what I gotta do is, from my total angle 180 degree, I gonna minus the inner angle and just divide it by 2. That is all we gotta do. The reason that I'm dividing 2 is because imagine that's unknown X and X. Well, same thing added together, plus 120 should give you 180. So inverse operation, by process of doing that, we get the conclusion that unknown angle, it's just finish up by divided by 2. Let's go with that. 180 minus 120 is 60 degree and divided by 2. So that means Z, we found it as 30 degree. So now we know few more clue. We know that, again, I gotta be delicate over here. Same thing. We know few of the angle now. We know this angle is 30. That angle is 30 degree also. But Y angle is the one that include not only angle from the triangle on the top left corner, but also the bottom angle together. So that means sometimes the simplest way is find out every single angle. Fortunately, we know part of this angle. It's gonna be exact same as what I wrote over here because, not thrown on scale, 100 degrees are at the top, and radius is AO and BO, so they're equal distance to each other. It's just a obtuse triangle, but isosceles triangle. So these angle, if I find it, that's actually 180 minus 100, then divided by 2. That's 80 divided by 2, so it becomes 40 degree. So I know more angle now. This angle is 40, that y is also 40 degree. Then we are almost at the end. We can also use the same logic for my bottom triangle over here. 140, identical length. So like I did in previous one, 180 minus the top angle, then divided by 2. That's 40 degree divided by 2, thus 20 degrees, something like that. Then I know what goes to each of them inside of this diagram. We literally and practically found every single angle that you can find in this diagram or archaeologist site, if you will. Then all you gotta do, add this to angle y, 40 plus 20, that's 60 degree. Did I use any of the formula? No. Did I use any of an inscribed angle? Well, technically not for this example, but you can still use it. For instance, if you look at this angle 140, that is a central angle. If I use the arc of B and C, if I look at my inscribed angle, which is located over here, that also used my B and C arc as one of the connecting bottom section. So you can actually do 140 divided by 2 to get it, which is 70 degree. You can do that. Or if you like to go this method to find out the angle y, simply what you can do is having a focus on the arc AC connecting with the center. We already know the central angle 120 and the inscribed angle that connects to the outside, aka the circumference area, which is B in this case. It's just half of 120, which is 60. So you can use inscribed angle and central angle too. Probably y is actually easy if you go with the inscribed angle method instead of what I did, which is triangle situation with isosceles triangle. But again, do I differentiate the method and mark you guys wrong if you did the other way? I don't think so, because we prove mathematically either using triangles angles or central or inscribed angle in circle property. So it is 100% your choice. All right, that was my examples for today's class, which was everything that we learned about circle properties, starting with inscribed angle, central angle, tangent line, and perpendicular bisector, and how these can be combined together for a real life situation. It's a apply question. Your homework is from your textbook, MathLink 9, page 385, 20, and 21. 2 questions from there. Page 392, 19 and 20. Page 402 and 403, number 15 and 22. So 6 questions. For the rest of the block, I want you to give those, give it a shot. And next class, I will go over those at the beginning. See you.